Welcome back to this maths class. Today we want to see what we call remainder theorem. And what does this theorem say? Suppose we have function of x which can be expressed in the form of polynomial. Now this function of x, if you divide it by x minus a, what you will have is you will have another function. Let's call it g of x, which is 1 degree less than the degree of the function of x. What that means is that if you have x raised to power 4 here, by the time you divide by x minus a, you will have x raised to power 3. That's where it will start from. So if you divide the function of x by x minus a, then you will get another function which is g function of x, which is 1 degree less than the degree of the function of x. Then the remainder, you will have the remainder, and the remainder will be the one that still needs to be divided by x minus a. Then we can now say fx. Now we multiply this by this. Then you have g of x. Then if you multiply this by this, this will cancel, plus r. Now, if you now have the f at a, just put a here. A minus a is 0. This. Then you have plus r. 0 multiplied by this is 0. Therefore, f of a equal to r. So what this theorem is saying is that if you divide the function of x by x minus a, you will get the quotient, which is another polynomial that is 1 degree less than the degree of the function of x. And then you have the remainder still to be divided by x minus a. And then if you put the function at a, it means you will now get your remainder, which means your remainder is just putting the function at a. So let's see the example of this. Now let's look at this example. Suppose you have the function of x to be this, and you are dividing it by x minus 3. The question says, what will be the remainder? So very simple. Don't forget that we said the remainder will be f of a, which means it will be f of 3. So once you get the function at 3, that will be the remainder. That's the last proof we did. So what you do is this, just net this one, put this one in a netted form. This is 1, then you put your x. So there's no need of putting this 1, since it is 1. So you put x, then plus 3, the next coefficient, 3, then bracket it, put your x, and then minus 13. Put this one into bracket, and then put your x, then minus 10. Then you now put this 3, f of 3. So this is 3 plus 3, 6. 6 times 3, 18. 18 minus 13, that is 5. 5 times 3, 15. 15 minus 10, and that is 5. So remainder, if you divide this one by this one, is 5. So your r equal to 5. As simple as ABC. Now we look at the second example. This is function of x, which is this. And the remainder theorem says that if you divide this function of x by x minus 2, you have a quotient of polynomial in the form of g of x, which will be 1 degree less than the degree of the function of x. That is, this is x raised to power 3. If you are dividing this by this, what we have, we start from x raised to power 2. And in that case, you'll be left with the remainder, which will still needs to be divided by x minus 2. And then we went on to say that in that case, if you say function at a will be our remainder, and we are asked to find the remainder. Therefore, we have to find the function at minus 2. That will be our remainder. So what we will do is to nest this one and then slot in our minus 2. Anything we get will be our remainder. So let's do the nesting. This is 2. Then put your x. The next coefficient, bracket it, and put your x. The next coefficient is minus 1, bracket it, and put your x, then plus 4. So to get our remainder, just put your x to be minus 2. So, and let's do that now. This is 2 times minus 2, that is minus 4. Minus 4 plus 3, that is minus 1. Minus 1 times minus 2, that is 2. 2 minus 1, that is 1. 1 multiplied by minus 2, that's minus 2. Minus 2 plus 4, that is 2. So our remainder will be 2, which means if you divide this by x plus 2, the remainder will be 2. You can try it using long method. You will still get answer to be 2. Until I come across your way again, I want to say bye.